Hello and welcome. Myself Professor Vikash Kataria, and you are watching lecture number 11 based on operating system. Today I am going to cover topics are concurrency and their key terms of concurrency. Okay, so let's have a look. The first question arises, what is concurrency? So before understanding the concurrency term, we have to know the nature of operating system. So let's have a look what kind of operating systems, what kind of nature they can have. So operating system can be variety of as far as their processing is concerned, it may be have variety of operating system. The first is multi-programming or multitasking. Second, operating system can have multi-user. Third, operating system can have multi-processing. And fourth, operating system can have distributed processing. If we talk about the multi-programming or multitasking, that means multi-programming involves multiple processes on a system with a single processor. So if we have a single processor, we can opt to the multi-programming as well as multitasking. Right. It can also achieve if we have multiple processor in a single system. Okay. It allows running several processes at once. Okay. So the multi-programming and the multitasking is one kind of nature of operating system, where operating system can deal with the single processor and single processor can manage multi-processes simultaneously. Okay, this kind of environment we said as a multi-programming or multitasking. Second nature which might have by the operating system is it can be work in multi-user environment. That means several users using it at the same time. We can take as example of Linux environment and Unix environment. They are multi-user operating system. Several users interact directly with the kernel. Okay, that is why it is multi-user environment. Third, the multi-processing, that means we have number of processor. So multi-processing involves multiple processes on a system with multiple processes. Okay, so if we have multiple processor, definitely each processor deals with the individual queue of processes. So automatically multi-processing can involve. And the fourth is distributed processing. Distributed processing involves multiple processes on a multiple systems. Okay, like a Google server, it is one kind of distributed processing. Anytime if user press the URL www.google.com, for the better response it provide very fast. It provide the home page of Google to a user very fastly. Okay, so these features can be achieved by giving each process a slice of time on a processor and a slice of memory for running and allocating resources as necessary. Okay, so an operating system, let's have a look. An operating system can be, the first is, as I told you, it may be multi-programming or multitasking. Second, operating system can have multi-user. Operating system can have multi-processor, multi-processing. And operating system can have distributed processing. Okay, I cleared the term multi-programming, multi-user, multi-processing and distributed processing. Concurrency occur in that manner if more than one processes concurrently or simultaneously wanted to execute their own context into the primary memory. Okay, So concurrency processing is the central to operating system and their design. Okay, what might happen is all of these involve cooperation, competition and communication between processes. If we look at any scenario of operating system, whether we talk about the multi-programming or multitasking or multi-user or multi-processing or distributed processing, in any one of the scenario, all of these involve cooperation, competition and communication between processes that either run simultaneously or are interleaved in arbitrary ways to give the appearance of running simultaneously. Right? So I'm going to mention here all of these involve cooperation, competition and communication between processes that either run simultaneously or are interleaved in arbitrary ways to give the appearances of running simultaneously. So in any one of the manner there may be cooperation, that is requirement, essential terms. Cooperation should be there, competition may be there and communication. Okay, so all of these involve cooperation, competition and communication between processes that either run simultaneously or in interleaved manner. Okay. Concurrent processing is the central of operating system and their design, means it cannot be achieved if users are concurrent, if multiprocessors are trying to achieve more than one task. If we talk about the distributed manner where client and servers are there, okay, so it cannot be avoided in that manner. So if we have multi-programming or multitasking, multi-user, multi-processing or distributed processing, there might be chances that there may be concurrency occurs. So concurrency is nothing, just as multiple processes wants to execute their own context into primary memory in interleaved manner. Okay, so if more than one processes are in the primary memory, definitely they are trying to access the shared resources. Right. So concurrency cannot be avoided because suppose users are concurrent. So a person can handle several tasks at once and expect the same from a computer. So if users are concurrent, that means more than one users are working simultaneously. If one user perform one application or one process, then there is number of users, so definitely there might be so many processes into the primary memory at the same time. So if users are concurrent, we cannot avoid the concurrency. It should be more than one process at a time. Second point, the multiprocessor are becoming more relevant. The internet is perhaps a huge multiprocessor. So if we have multiprocessor, that means multiprocessor are becoming more prevalent. Okay, the internet is perhaps a huge multiprocessor. Point third, if suppose distributed system is a naturally concurrent because it has connected with the certain number of systems and each one has the replica of file and folders resources. Fourth, we can also take an example like windowing system is naturally concurrent. Operating system can perform so many tasks at the same time. It may be naturally concurrent. Input output is often slow because it involves slow devices such as disk, printer. Many network operations are essentially slow input output operations. So when doing input output, it is helpful to handle the input output concurrency with other works. So we can't say only the nature of operating system can occur the concurrency problem. Due to slow input output of devices may be concurrency generated. So it can also be generated by the input output devices and their slow speeds. Okay, so we cannot avoid the concurrency if users are concurrent, if multiprocessors are there, if distributed systems are there, and like a Windows system and the slow speed of input output devices. So let me mention here, we cannot avoid concurrency if first is if users are concurrent, second if we working over multiprocessor environment, multiprocessing environment, suppose we work on distributed manner, distributed system manner. Fourth is slow speed of input output devices or network devices. So in that case we cannot avoid the concurrency. They are definitely sure concurrency will be there. Okay, we cannot avoid in those situations. So concurrency, I hope you getting my point. What is concurrency? So concurrency is nothing, just more than one processes working simultaneously or executing simultaneously into the primary memory of a server. It may be generated in a single processor system, it may be generated on multiprocessor system or distributed system. Because users are concurrent, more than users are working simultaneously, so user can perform the several tasks, the same expectation user put from the operating system. Okay, so in that manner concurrency may be there. Now let's talk about some key terms related to concurrency. The first is atomic operation. Atomic operation, that means, let's discuss on atomic operation. A sequence of one or more statements that appear to be indivisible, that is, no other process can see an intermediate state or interrupt the operations. Means if more than, suppose I am taking example of two process P1 and process P2. Process P1 has their own context it have own TDS. Process P2 also has own context, it has own TDS. So process P1 should not interfere in the working of process P2. So both are executed individually. So process P1 will not take care about the process P2 context, and process P2 will not take care about the process P1 context. Okay, so it should not be the none of their business. P1 should execute their own context, P2 should be executed to their own context. It should not be interfere to each other. This is called atomic operation. So let me describe the term atomic operation here. A sequence of one or more statements that appear to be indivisible. Indivisible, I mean to say that nobody can look after to their other context of the process. Okay, process should be take care or visible to their own context. It should be take care about their own context, what's running in text portion, what's running in data portion, and what should be running into the stack portion, right? So a sequence of one or more statements that appear to be indivisible, that is, no other process can see an intermediate state or interrupt the operation. Interfere, interrupt in working of P2, right? Now second option is critical section. What exactly the critical section is? A section of code within a process that requires access to shared resources and which may not be executed while another process is in the corresponding section of code. Okay, so let me write here: a section of code within a process